In this question, it is known that 50% of the customers who enter a restaurant order a cup of coffee. If 4 customers enter the restaurant, what is the probability that more than 2 of these customers order coffee? Assume that what any customer orders is independent of what any other customer orders. So for this to be a binomial distribution, or to use a binomial distribution to solve this problem, you need to have 3 things in place. The first thing is that either success or failure are the only 2 options. And in this question, ordering a cup of coffee or not ordering a cup of coffee are the 2 options, success and failure. And the probability of success, the probability that someone who enters the restaurant orders a cup of coffee is 50%. Because it is known that 50% of the customers who enter do order a cup of coffee, then what you can say is the chance that anyone who enters the restaurant, there's a 50-50 chance that they're going to order a cup of coffee. So you could say the probability of success in this case, which is ordering a cup of coffee, is going to be 50%. And the last condition that makes a distribution binomial is that the trials are independent of each other. And the trials in this question are what the customers order. They either order coffee or they don't. And here they're telling you assume that what any customer orders is independent of what any other customer orders. So the trials are independent. Those 3 conditions, success or failure, constant probability of success, and independent trials are in this question, which means that if X is the number of people who order coffee, so number of coffees, I'll say, so X in fact is a binomial distribution with N being the number of trials, which is 4 for customers, and probability of success, the probability of ordering a cup of coffee is 1/2. And from here, thereafter, the probability that more than 2, so that would mean X would be more than 2, and the values of X that would satisfy that would be X is equal to 3 or 4. And using the formula, so the probability that X equals X is equal to N choose X, P to the X, and 1 minus P to the N minus X. So using that formula with these 2 values one at a time. So first of all, the probability X equals 3 is going to be 4 choose 3, P, which is 1/2 to the power 3, and then 1 minus P, which is also 1/2 to the power 1, and plus for the probability that X equals 4, it's going to be 4 choose 4, P, which is 1/2 to the power 4, and then 1 minus P, which is 1/2 to the power 4 minus 4, which is 0. And from here, the next step is 4 choose 3 is equal to 4, and then same base here, and you're multiplying those 2 terms, so you would add those powers, so you'll have 4 times 1/2 to the power 4, and then plus, and 4 choose 4 is equal to 1, and all of this is just going to equal 1/2 to the power 4, and then in the next step that becomes 4 times 1 on 16 plus 1 on 16, and so you've got 5 lots of 1 on 16, which is 5 on 16, which is the correct answer for this one. So that's how you use the formula to figure out this type of problem. Wording is critical. More than 2 it asked for, which would mean it would have to be 3 and 4 for the X values. And so yeah, that's how you do this question.